Welcome everyone. Okay, so let's get started the evening session. For the first talk, we are very happy to have Edgar Shaghoulian from Penn, and he will tell us about central dogma and the cosmological horizon. So please start.
Great, thanks Tomonori and to the other organizers for inviting me to speak. It's always exciting to speak for the audience where a lot of these kind of key ideas were developed. This talk I made keeping in mind that it's early here and late there, so it's a little formula light, and I'm going to try and communicate the main points without a dense set of formulas. But if you want details at any point, please ask me. I'm happy to chat about them, maybe in the Q&A session. So let's get started. Something is not working. Okay, that's fine. Okay, so what is the central dogma? In case people are not familiar with this term, it's something I'm sure people already know, maybe by another term. It's the following statement that from the outside, a black hole can be described in terms of an ordinary quantum system with area over 4g Newton degrees of freedom, which evolves unitarily under time evolution. It interacts with its environment and evolves unitarily, but it's otherwise an ordinary quantum system. And a lot of people have contributed to this understanding of this idea in our community. I just listed a few names, which I think are probably the most prominent ones: Bekenstein, Hawking, 't Hooft, and Susskind. But it's a natural idea. And the computations of the page curve from a few years ago, you could think of as evidence for the central dogma. Right when saying it has area over 4g Newton degrees of freedom is the same as saying the Hilbert space has e to the area over 4g Newton number of states. And right when that bound is about to be threatened due to the entropy of Hawking radiation, a transition happens and the bound is satisfied, meaning it seems more likely that it is just an ordinary quantum system with that many degrees of freedom. So that's one way to think about the computations of the page curve. So, the idea for the central dogma in the case of black holes was the fact that these black holes have a horizon, and the horizon is the source of this entropy, this A over 4g Newton entropy. But we also have cosmological horizons, and they also have an entropy, as first pointed out by Gibbons and Hawking. And it's given by the same formula. The area now of the cosmological